Hello, this is Yannis from Any Repair. Today we will go through an Intel NUC i7 8th generation mini PC that came to our lab without having any USB functionality. So let's go and see how we'll deal with this damage. Okay, this is the Intel NUC. It is an Intel NUC, you can see it is an 8th generation i7 that came to our lab, as I said before, without USB functionality. Now I will try to plug the power supply. It is not having a battery. And my HDMI cable from my microscope view. And I will take my mouse and check if we are going to have any USB functionality or whatever we can determine by plugging a USB device. You can see the amps are rising. I am not having any display. I will now activate my microscope view in order to see the image coming from the NUC. I will power it on. You can see the amps, now the display. We are having display. Now I will plug my mouse in the front USB. It is always the opposite side, you can see. The mouse is not functioning. I think it is not taking any 5 volts in order to work. You can see no light. It's an optical mouse. It's not a laser mouse. So we should have a red light. We will plug it in the next USB. And now on the rear USB, nothing at all. So no power on the USB ports. So we must disassemble and check the board in order to check if we have any short or power rail missing or something. Let's go and disassemble. We are quick. The board is off. And now we will try to find if something is abnormal with this board. I have removed the DDR4 memory sticks. And now I will check near the USB ports because there are always something to control, such as MOSFETs to control the power rail. So we will check for MOSFETs that are near the USB ports. I don't think that these are the coils that are producing the 5-volt power. Let's turn it upside down. Now we can see something like a MOSFET that probably feeding this USB port and the other port too. So we must start from there. We must check if we are having a short directly on the 5-volt USB. So we will activate our multimeter in beeping or diode mode to check if we are having something abnormal. Okay, we are in beeping mode. I think we must be in diode mode. We can see that we are having a correct input for the USB. So we are not having a short on the USB ports. This is the positive. This is feeding this port, and the other is feeding the other port, and we're having 5 USB clear from shorts. So we must see if the MOSFET is switching. If the MOSFET is switching in order to pass the 5 volts from the coil or from the rail to the USB port. So we must check the MOSFETs that are controlling this rail. But what I haven't done is to check the coils for shorting, and that I'm doing right now. If I'm having a short coil, a shorted coil, this is not a coil, this is the capacitor that is feeding the USB. This is the MOSFET that is feeding the USB, that is switching in order to provide power to the USB port. This is the capacitor, which is connected directly to the MOSFET, and the other side of the MOSFET is, you can see that is directly connected to the MOSFET. And on the other side of the MOSFET, we are having the power supply before the MOSFET is switched. There. Oh, and you can see we are having a short. We're having a short before in a main rail, a USB main rail. Let us check for shorting on the other MOSFET, the other side. You cannot see it, now you can. It is having the same short, you can see, the same short, so it is a common rail which is providing power to the MOSFET, and after switching, the USB are having their power, but the primary 5-volt rail for feeding the USB is short. So we must find the cause of this shorting. Let's check. Yes, this coil is short. This is not, and maybe we are having our culprit. I think this coil is providing power to the MOSFET. Let's check. Of course, it is this coil providing the power to the MOSFET. You can see the difference. It's having 0.30 ohms to ground, but directly connected to the MOSFET. You can see it. So it is connected with this MOSFET directly. So what we must do is to provide power to this coil and check what is heating up. From the ohms, I think it is a capacitor that is holding this power down, but let's check. I will use only isopropylic alcohol, and I will touch the shorted side of the MOSFET with my power supply in 2 or 3 volts. It's not the volts that you can see in the upper left. You can see that something is heating, and it's sure a capacitor, but let's find out which capacitor it is. Let's go and zoom better. I think on the right, the capacitor on the right is heating up. Let's touch again. Let's moisture this side and check. Yes, this capacitor on the right, I think it's damaged, it's shorted. We will add some isopropylic again and check again. I will zoom out in order to see better. Now I'm touching the MOSFET and boom. Yes, it is this right capacitor. The right capacitor is wrong. I mean, the capacitor on the right is wrong. And we must remove it. We'll add some flux. I will not use my hot air gun. I will use my soldering iron and my tweezer, not hot tweezer. I don't have a hot tweezer. You can donate though. Just joking. So I will use a soldering pen and plenty of solder, and I will wiggle with the tweezer in order to remove the broken capacitor. And I'm having a mess there, but it's okay. We're having a week. Fortunately, we'll add some flux. We will use our wick. Because our soldering pen didn't do the job. So, soldering pen and wick, in order to absorb the excessive solder and the bridging between the capacitors, and we are okay. Of course, the capacitor will be replaced, but first check for shorting. I think that the coil is free from shorts. No beeps. And if we switch to the MOSFET side, it is clear. And now what we're going to do is power on the device, the NUC, the mini PC, and check if we are having power on the USB. So we don't need to put this mini PC on its chassis because it is all on board. I have just plugged in one RAM stick. I will plug the USB on the rear USB. I think these are the rear USB ports, and I will plug and it's charging. When I touched my power supply, it is charging the device that is connected to the USB because it is from BIOS to give power to any USB connected. It is not on, but it feeds any USB that is connected to the USB port for charging purposes. So I think the problem is solved, but I will power on the NUC in order to see if we are having any USB activity. But first I will charge my mobile device, and it's charging. You can see that it's drawing 0.165 milliamps, 164 milliamps. And now I will try to boot this NUC with a Windows USB stick and my mouse on it, and I will connect the HDMI cable too to check if we are having USB activity, not only power. The HDMI is connected. I have put back the NUC partially into chassis. Windows 10 USB drive and the mouse on it, and let us boot. HDMI activated, so we are booting. We have an Intel NUC, we have mouse with power, with LED activated, and now we wish to have a USB drive recognized and boot from USB in order to install an OS. It is booting. You can see the activity. It has loaded the primary installation from the USB. We are good. We will try to press the cancel button and close this window, although it's too small. We are okay. The device is fixed. That was the repair as you saw. If you like this video, consider like, subscribe and share. Thanks for watching. See you in another repair. Bye.